Okay, so hello everyone. We're back again for another Women in Tech webinar. So this webinar aims to showcase women who are leaders in their field and primarily uses Google Cloud Platform in their work or in their personal projects. For our fifth Women in Tech webinar, our speaker is a software developer from Encore Sendirian Berhad in Brunei, building applications in the cloud. She is an organizer in Google Developer Group and Women Tech Makers Brunei and gives talks and runs workshops about GCPU services. She likes ultimate frisbee, yoga, and tinkering with electronics. She will discuss how Cloud Build, GCP's serverless CI/CD platform, can help you deploy your functions automatically upon a simple commit change. She will go through how to set up Cloud Build and best practices to keep our repositories tidy. To not keep you waiting, I present to you Xing.
Hi everyone. My name is Singing, and today I'll be telling you about tidying up Cloud Function deployments on with Cloud Build. Is my screen visible? The slides?
Yes, it's visible.
All right, awesome. Okay, so Jasmine has given me a lovely introduction, but I'll just quickly restate. I'm a software developer at Encore, and I'm a speaker organizer at GGG Brunei. So I run talks and workshops about the cloud. So on today's agenda, there's a couple of things. So firstly, we'll give a quick primer on what are cloud functions in case you have not used it before or you don't know what that is. I'll tell you all you need to know about it. And then we will go on to how do you continuously deploy cloud functions with Cloud Build. So as I'm sure you are familiar with, Google Cloud Platform or GCP has many different services to help you build your application. So if you need computing power, anything from virtual machines, containers, there's a place to run them on GCP. And if you need data analytics services, from BigQuery to data transformation pipelines, databases of all kinds, and even if you're in a niche area like IoT, there are even services that can help you manage your fleet of IoT devices. In fact, there are so many different services that it's I cannot possibly fit them all onto this one slide. So to build an application, you typically connect several of these GCP services together to perform tasks. So here I'll give you an example. Let's say I'm going to build an image annotator. So whenever a user uploads an image, let's say to cloud storage, which is a file system essentially, I would like to get the label from the image. So I would use a machine learning API, for example, to capture the label of the image, like what labels would describe the image the best. And then once I get the labels, I would like to upload it to Firestore. So this is my whole flow. And this is what the annotated image service should do. Now, question is, how do you build it? An easy answer would be to use Cloud Functions, namely because Cloud Functions is event-driven. So that means whenever event occurs, for example, in this case, when you upload an image, it will then trigger the function to perform a small task. So this is what the Cloud Function. So now I'll show you how to write the Cloud Function. Firstly, the directory structure. So you have a main repository for your project, and let's call it WDA, for example. Then for each different cloud function, you should have its own. They should have its own separate folder. So in the folder, you contain the function code. In this case, I'm using Go, but Cloud Function also supports Java, Node, Python, and several others. And of course, this folder also contain the dependencies. So now that we have the directory structure, this is what the function looks like. And as you expect, it's essentially just a single function. This function is triggered by a cloud storage event. So whenever a file is uploaded to cloud storage, that means it should take the GCS event as its argument. So this event struct should contain the metadata about the file, information about the file that was uploaded, and etc. etc. So from there, the rest of this is essentially pseudocode on. Firstly, you get your URI, where the image is located, from your GCS event, and you send it to your Cloud Vision API to get the labels, and then upload the labels to Firestore. And this is essentially the annotate image cloud function. Now that you have the function, you can then deploy it using the gcloud command line tool. It's as simple as gcloud functions deploy, name of your function, followed by several flags that will indicate what sort of function it is. So in this case, this is a function that is triggered by a GCS event. Therefore, you have to specify which cloud storage bucket it should be triggered by, and you should also specify the type of event. In this case, it says here Google Storage Object Finalized. That means it will be triggered whenever a file is uploaded or is newly created, or a file has been updated on this bucket, which is specified by trigger resource. Remember, cloud functions can be written in several languages. That's where the runtime flag comes in. You specify which language it is and the region in the project. And that's it. That's how the cloud function works. I'll show you a quick demo of what it should look like. So to avoid having to wait for my function to be uploaded, I've already deployed the function for you. And it looks like this. Here's the label image or the image annotator. And you can see it's triggered by this bucket, by uploading something to this bucket. Here I have the bucket, and I'm uploading to the up. This is the bucket. And give it a moment. This is the folder that I'll be uploading images to. And now I will upload a photo that I want to get images, labels from. So here I have some lovely pictures of animals being best friends. Here we have a dog and an elephant. Let's upload it, and let's see what labels does Cloud Vision API give us. So it should, the function should then run. So if you go to the function and you go to the logs, you should be able to see it being invoked. And once it invokes, it should then upload the labels to Firestore. Here I have Firestore open. So just give it some time. And here you can see function executed. Function execution has started, and it has finished for OK in less than a second. And here you can see in Firestore, the labels have been uploaded, and the label that is most relevant to the photo you saw earlier is water, and with a score of 0.979. Of course, I'm just using the general machine learning API. If you want to, for your business use case, you might want to retrain a machine learning model for a specific business use case. You can use that model instead, but I'm just using the general machine learning API. And it also contains the information on where the image is. Going back to the slides now. And now you've seen a demo on how the Cloud Functions works. So Cloud Functions, they are event-driven and fully managed. That means you don't need to worry about fully managed, meaning you don't need to worry about provisioning infrastructure, where to scale up or scale down. It's serverless. It handles everything for you. You can just focus on your business code. So it's event-driven, meaning it is triggered by events. So you don't only, it's not on, you don't have to use it in with a cloud storage. It can also be triggered via different means, for example, using HTTP endpoint, or whenever you post to a topic on Cloud PubSub. Here's another example. Let's say you can also trigger it via a cron job, in this case using Cloud Scheduler. So you can have another Cloud function for updating IoT device every hour. So every hour, Cloud Scheduler would ping the Cloud function, and you get weather data and you update device config. So a lot of different ways you can use Cloud functions. In fact, during the course of a project, I find myself using quite a lot of Cloud functions, and this is where it gets a little messy. It's easy to create a lot of Cloud functions, but how do you manage the deployments? You would want version control. You would want to automate testing and deployment. You don't want to just deploy it as a G-Cloud command from one of your developers' laptops, right? So you want a consistent, systematic way of doing testing and deployment. So this is where Cloudbuild can come in. It's GCP serverless CI/CD platform, and it allows you to create build pipelines. Essentially, what you do is first define your build steps in a YAML file, then deploy that, and Cloudbuild can then spin up containers to execute each build step. So you have different build steps, each of them doing something, maybe one for testing, another for deployment, and it would spin up a different container for each step. It's a 3-step process to use Cloudbuild. So first, define the build steps in the YAML file. Next, on Cloud Console, connect to a repository, then create a trigger. So the trigger would be looking out for any changes to the code. So if there's a certain change to the code, it would then run the pipeline, the build pipeline. And then you push the code to repository, and it should trigger the Cloudbuild trigger, which would then build and deploy a pipeline, your function. I'll show you how it works. We'll go through each of them step by step. So firstly, we will write down the build steps in the Cloudbuild YAML file. First, it helps if you have a good idea of what your build steps look like. In this case, it's going to be a 2-step process, asynchronous. So firstly, you test the function, then you deploy it to Cloud Functions. You can also have build steps that are running in parallel, but we'll not be covering it for this talk. So on your YAML file, it looks like this. You have steps, and you would then specify the 2 steps. Firstly, for testing the function, for Go, it's just Go test. So you can just run it simply like this. And then you have another step here, which deploys to Cloud Function. This is the basic anatomy of the YAML file. So for each step, it contains a couple of basic things. So firstly, you have to specify which container image you're using to run this build step. So for this step, for example, I'm using the G-Cloud Cloud Builder container image. And the Cloud Builders are essentially a bunch of container images which has already some commands pre-installed on them. For in this case, the G-Cloud command line tool is already pre-installed onto this Cloud Builder. That means you can just straight away use the G-Cloud command. Entry point is already set as G-Cloud. So the rest of the arguments, you can then add it to this argument. I'll show you how later. And of course, you can specify the ID, which is helpful if you have parallel build. So you have build steps which are running in parallel. You can use IDs to specify which are the next steps, and so on and so forth, which we'll not cover here. So for the YAML, the basic deployment, remember how to deploy Cloud Functions. It's G-Cloud functions deploy annotate image. This is the original command. But in the YAML file, it looks like this instead. So here we are using the G-Cloud container image, whose entry point is already G-Cloud. So you just have to feed in the arguments. So functions, deploy, annotate image, and the trigger resource, etc., etc. Now you might be looking at something that has changed. So here we have a couple of variables which has the $ in front of it. That is because it is a variable that is substituted in during the runtime. This makes it easy for us to reuse the Cloudbuild YAML files if needed be. So you can, at different runtimes, you can substitute in different variables. Look at these 3 here. project ID variable is actually automatically given. You don't have to specify at all. And here, so for each function, it should have its own Cloudbuild.yaml file. So remember, we have the WDA as the main repo. Then within that repo, it has many different cloud functions. So annotate image is one, and under annotate image folder, it should have the YAML file for that cloud function. And a bit of extra thing that you have to put into your YAML file is you have to specify which directory it is under that step. This is because this function is inside that directory. So just specify the directory here. All right, so now we have the build steps in a YAML file. Next thing is to set the trigger on cloud using the Cloud Console. So here's the plan. So we have here we have a couple of cloud functions, and you inside this WDA repository. And so when you push this WA repository, what you want is, if there are any changes in the annotate image folder, you should deploy the annotate image function only. You are not to deploy the second cloud function. If there are any changes for the second cloud function, it should only deploy the second cloud function and not annotate image. So to do this, we are going to create two different triggers. One trigger for each of the different functions. So annotate image has its own trigger, Cloud Function 2 has its own trigger. To create a Cloud Build trigger, it's simple. Go to Cloud Console. Under Cloud Build, there's triggers. Connect your repository if you haven't already, then create the trigger. You'll be then to a form that's pretty straightforward, but I will point out some important bits. Firstly, you need to specify which event will invoke the trigger. So it can be if you push to a branch, if you push to a new tag, or pull request, but we'll be using if you push to the latest branch. Then you can specify the branch here using regular expression. Then next, we are going to create the build trigger here. So here it says there's a box for you to specify which are the included files, meaning if any files that are within, if any of the files specified here have changed, it will then cause a trigger. Otherwise, it will not trigger the build. So in this case, because let's say we're building the trigger for the annotate image function, that means if any files inside the annotate image folder changes, this should cause the build pipeline to start. You should also specify where the Cloud Build configuration file is. In this case, it's under this folder. And remember when I mentioned you can substitute in variables during the build? This is where you would state it. So it's in that form as well. There's this spot under substitution variables, and you can specify the bucket ID is this bucket, the region is this region, and as you can see, it will then substitute it in during runtime. Another thing you need to do is you have to give the correct IAM roles to the Cloud Build service account. This ensures that the Cloud Build has the correct permissions to be able to deploy the Cloud Function. The roles are Cloud Functions admin and service account user. So this is what your Cloud Build service account will look like. It should all be automatically there, and just give it the roles. And that's it. All that's left is for you to push the code to repository, and it should cause the Cloud Build trigger to run, which would then build and deploy your Cloud Function. I will now show you a quick demo. So going back to the Firestore, as you remember, we have already run the function once. And you can see here that it adds the most relevant label to Firestore. So when I upload an image, only the most relevant label is captured. So what if I want to capture more than one label? So I want the top 3 labels to be captured. So now I'm going to update the Cloud function, and I will do that here. So this is my Cloud function. Here is the exact function. If I scroll down, there's a label image here, and that's the function. As you know, you had the file URI to tell you where to get the function from the GCS event. Then you can get the labels by sending it to the Cloud Vision API. You get the labels, then you upload it to FileStore. So there is a point here which says it only keeps a certain number of labels. So Cloud Vision sends you actually several labels, starting from arranged from the most relevant to the least relevant, and only keeping one of the labels. So now I want to keep more than one. So let's say I want the top 3 labels to be stored on Firestore. So I will save this. I will then commit it. And change the max number of labels to 3. And I will push to the latest branch. So it is pushed, and to save time, I have actually already added the trigger to my GitHub, to the repository. So here you can see there's actually a little tick here. There will be a little green tick if the Cloudbuild has ran as expected. But here it's a yellow circle because it is running. So there are actually 3 triggers on this repository, but you can see for the other 2, it's grayed out because it is not a relevant. The trigger found this change in these changes in this commit irrelevant. That's because the included file might be different. So I specified the included files to be for those triggers to be some other folders, and for CloudFun tidy, the included files. Some data from the included files, some code from the included files has already changed, and this caused the Cloudbuild to run. Remember, if you have any questions, feel free to drop it in the chat, and I'll have a look at them later. So it's still yellow, that means it's still running. And you can actually look at your build via the progress of your build via the console. So here, under Cloud is the build history. You see it's still running. And when it's done, you should be able to see on essentially what it's doing. It's deploying the Cloud function again. So under the logs of Cloud functions, you should be able to see it. So here, an update is in progress. And let's see if it's finished. Still going on. Take some time. Oh, I think it just finished. And so that means if I upload a new picture now, it should give me the top 3 labels, relevant labels of that image. So let's upload another file. And let's have these 2 buddies. And if we look at Firestore, here it's already completed. And it has uploaded the top 3 labels for that image. And as you can see, it's water, dog, and vertebrae, because those are apparently what the machine learning API found most relevant. Going back to the slides, all this code will be a link to the code I've used for this talk will be available later. So if you want to add automated testing, it's as simple as changing your build and your YAML file. So you just add another step for running tests and deploying your function. And if you are fetching private dependencies, example from GitHub, there is a couple of extra steps. So first, you have to generate a public and private key pair using SSH keygen. Then for the public key, you have to add it to your GitHub repository as a deploy token. Then for your private key, you have to add it to GCP's secret manager. So it's another service that will take care of secrets for you. For example, API keys, deploy tokens, and the like. Then you add these few steps to your YAML file. And it's firstly, fetch your secret from the secret manager and save it to a volume. The volume is something that's attached to different steps on your Cloudbuild. So remember, Cloudbuild, each step is actually a container. The containers, they're actually isolated from each other. So that means if you want to persist some data, files, information between subsequent build steps, you will have to use a shared volume, which will then be attached to the containers, and you can then draw information that you got from previous step in the next step. Then you have to configure Git to use private SSH key to be able to get the code from your private repository. So this is what like a couple of extra steps: fetch your SSH key, then configure Git, then deploy your function. So Cloudbuild is very handy, but it's not just for functions. You can use it to build container images, and you can deploy to Cloud Run, GKE, App Engine, and you can also build applications with Bazel, Maven, etc. And of course, you don't have to just use the Cloud Builder's container images in building your applications. You can also use custom container images. So as summary, you can reliably and painlessly deploy Cloud Functions with Cloud Build. To use Cloud Build, it's as simple, it's just 3 steps. Create the YAML file, create a trigger, then commit your code to a repository and watch the magic happen. Each function has a separate Cloud Build YAML file and a folder, and also you have to create a trigger for each function. In this trigger should invoke the build only if that Cloud Functions folders contents have changed. For private repositories, make sure you get a deploy key and you store it safely in Secret Manager. If you need any more information, you can always check out the documentation. And that's it from me. If you have any questions, feel free to drop in the chat, let me know, or you can find me on Twitter. The slides are here, and you can also try out the code as stated here. Thanks.
Thank you so much, Xin, for that very informative talk. So far, we don't have any comments in the comment box. So I think they'll just reach out to you if they have any questions.
Sounds good.
So yeah. So I think that ends our Women in Tech webinar for tonight. Thank you so much again for speaking about cloud functions, and it was really very informative.
It was my pleasure. Thank you very much for inviting me. Have a good evening.
Have a good evening. Have a good evening too. Okay, thank you everyone for watching. You can always watch the replay at YouTube. We also share this in our Facebook group, GDG Cloud Manila. You can also follow us on our Facebook account, GDG Cloud Manila Events. So thank you for tuning in. Have a great evening.